So hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our Rising Brain pattern wise DSA sheet, and in this we were doing the array topic. Inside this we were following the sliding window pattern, and in this today we will solve subarray product less than k problem. So let's read the problem statement. The problem says given an array of integer nums and an integer k, we have to return the number of contiguous subarrays where the product of all elements in the subarray is strictly less than k. Means we will be given an integer array and we have to find the number of such subarrays whose product of all the number in that subarray will be strictly less than. Means for k 100 it can be till 99 but cannot be 100. Okay. Let's see the constraint. Constraint says the nums of length can be 3 into 10 power 4. Means if we will try to run the n square time complexity code, means 3 cross 10 power 4, n square will become 9 cross 10 power 8. And you know beyond 10 power 8 it might give you TLE. Okay. Now nums of I says it can be greater than equal to 1 and less than equal to 1000. So integer value in the array can be 1 or maximum 1000. Given k can also range from 0 to 10 power 5. Okay, how it will help us? It will help us to find the base case. So let's come on to the screen. Now here is our nums array and it is asking ki find the number of such subarrays whose product is less than is equal to k. So first let's see how many subarrays we can make here. So first subarray will be 10, second subarray will be 10, 5, third subarray will be 10, 5, 2, fourth subarray will be 10, 5, 2, 6. If you will see the product of 10, it is 10 only. Product of 10 and 5, it is 50. Product of 10, 5 and 2, it is exactly 100. And you know it is asking less than k. Means this cannot be the valid subarray. Similarly, here we will get 600. Hence, this is also not a valid subarray. If we will see another subarray, that is 5. Of course, it is valid. 5 and 2, it will give you 10. Valid. 5 and 2 and 6, it will give you 60. Hence valid. Now another is 2 valid, 2 and 6 valid and 6 valid. So how many such subarrays are there whose product is less than k? This is 10, 50, 5, 10, 60, 2, 12 and 6. So total number of subarrays are 8. And if you can see here the output expected is also 8. Okay, so the very first task is, don't you think if we will find all the number of such subarrays and we will take the product, and in the if condition we will simply check if this is less than, then we will do count plus plus, otherwise we will break. First we have to print all the subarrays, and you know with two for loops it is possible. How? We will run a for loop for int I is equal to 0 to I less than n, I plus plus. Now another loop for j, int j is equal to, we will run from I and then we can move either of the direction. Means if suppose I is here, so we can calculate the number of subarrays in this direction also or this direction also. Any one direction we can fix. So suppose we want to calculate in the leftward direction. So for sure we have to run our j loop from I, j greater than equal to 0 and j minus minus. Correct? So what will be the first subarray? If you will see, I will point to this and j will also point to this only towards left side until it is 0. So the very first product will be 10. So we have to take a product variable also to calculate all this. So here what we will do, we will create a product variable, and you know summation we initialize with 0 but product needs to be initialized with 1. Otherwise if you will initialize with 0, multiplying any number to it will make it 0. So hence here we will do product multiplied is equal to nums of j. Correct? Now we have got the very first value 10 and I know it is a subarray. Correct? And I know one more thing. If it is less than k, then we can count it in our valid subarrays. So basically we will initialize a count variable outside the whole for loop, and here we will see ki if our product is less than k, we can simply do count plus plus. Correct? Saying it is a valid. Yes. Next time our I will point to this fifth index. Correct? So when I will point to this, j will start from the same location I and j will run for I1 and I0. So in that time again product will initialize with 1. It will multiply this 5 and 10 also. So now I can say that this is another subarray with product 50, and if it is less than k, means we will do count plus plus. Similarly next time I will hit to this. So j will also start from the same index I. This and this. Now it is also a valid subarray, but when it will get multiplied, it will become 100. Correct? Yes. So in that case, this if case will not run for this. I can say ki if we fall in else case, then we will simply break that J loop. Yes. Now what will happen next time? I will go here. So again J will start from here. So obviously it will get multiplied and 6 is less than K. So it will be count plus plus. Next time 6 and 2 will get multiplied. Again it is another subarray. Again count plus plus. Next time 6, 2 and 5 will get multiplied and it is nothing but 60. Again it is a valid subarray. So hence count plus plus. And next time we will add this. And it is not a valid subarray. And hence we know that when it is not a valid subarray, and suppose there were one more number here, 5. So what do you think? When 10, 5, 2, 6 is not a valid subarray, do you think adding this extra 5 will make it smaller? No. So hence it is very important to stop our J loop at 10 only. So that is why we need to break that J loop, correct? And at the end of this for loop, we can simply return our total count till here, and that will be a valid code. And hence let's see the time complexity here. So time complexity will be I is running from 0 position to n position, correct? And J is also running from I to 0. So initially it will only run for 1, next time 2, next time 3, and last time it will be n. So it is total 1 plus 2 plus 3 to n. This is nothing but, and it will also run for n time, that is in nested order. So hence total time complexity will be O of n square. And you know this is the brute force approach. The solution might get submitted. Why? Because not for every approach it will run for O of n square. Because what if initially only it will get 10 into 10? So definitely J will stop here. It will not go towards this. So these many it is not reaching also, na? So that type of case will not allow it to run till O of n square. So generally it takes O of n square, but still it is very slow. So interviewer will definitely ask you the optimized approach. So before going for optimized approach, let's see the brute force code here. But if you remember the K case, K says it will be greater than equal to 0 and less than equal to 1000. So what was that base case? Base case says ki here we want K 0 also. And it also mentioned ki the number variables like integer value can be 1 to 1000. So what do you think? When K is 0 and the question is asking for strictly less than, not equal to also, strictly less than, and I know ki there will be minimum value 1. So is it possible to get any single subarray? No. Now let's think K value is 1. Even if it is 1, 1, 1, 1, you can think of ki yes there is subarray, but the value will be, the product value will be minimum 1 and we want less than K. Hence it is not possible. So the very first base case will be if K is less than equal to 1, number of subarrays will be 0. Correct? So we can add this. So now let's see the code here. In the code first we will add the base case ki K less than equal to 1, then we will simply return. And then we will count, initialize the count variable, and we will run the for loop for 0 to n. Correct? Now we will initialize the product variable with 1 and we will allow this J loop to run for I to 0 in negative direction or leftward direction. We will keep on multiplying every number, saying every new number is a subarray, and if that product is less than K, means allowed, we will do count plus plus, or else we will not allow the J loop to move forward. So hence we will break there. At the end, we will simply return count. And as you can see, the time complexity is O of n square. So when you will submit this code, this will get submitted, but this will be very slow. So how to optimize this? Let's see. Now let's see the optimized code for this version. As you already know, whenever we talk about the optimized code, we always thought about 4 different patterns in arrays. And those 4 different patterns are nothing but 2 pointers, sliding window, prefix sum, and cadence algorithm. 2 pointers we use when the array is sorted, correct, and we want 2 particular points to calculate length or to decide which pointer will move ahead, remember? But the very first reason is it should be sorted. Second, we use sliding window whenever we talk about everything in between of 2 points. So basically, if we are talking about this to this, we want everything in between, and that's what similar kind of thing we need here, correct? So we can think of using sliding window. Now prefix sum, you know, whenever we have to talk about continuous summation, okay, and here we want different subarray, but here we want the product instead of summation. So hence we can ignore prefix sum here. Talking about cadence, we consider cadence in sliding window only, but if the number, like in the number array, if my integer value can be negative and we have to calculate the maximum sum, then we go for the cadence algorithm. But you know here negative number is not there, so hence we can ignore cadence, we can ignore 2 pointer, along with that we can ignore prefix sum also. So hence we can go with sliding window because we want continuous subarray, but instead of summation we want a product here. Okay, works. If you remember, in sliding window what we discussed ki first we will take 10, then we will take 5, then we will take 2, and if the condition fails, then we will start shrinking. So first, if you remember, first what phase start? Expansion phase start. So right and left pointer both point to the same index. Now in the product variable, we will initialize with 1 and we will run a for loop for what? R. From where? 0 till where? N and R plus plus. Okay. Now what we do? In the product, we simply multiply our nums of our index value. So first we will multiply what? We will multiply this 10. Next time we would like to move to next index. Why? Because when we multiplied this 10, our condition was true because it is still less than 100, correct? So until the condition true, then we keeps on expanding, means expansion phase will continue, and once the condition breaks, then L starts moving from left side, saying it is the shrinking phase. But before moving this right pointer ahead, our task is to calculate the length if our index is valid. So to understand how we will calculate length, let's take an example here. Suppose we have 2, 3, 5 and 6, okay, and I want to calculate number of subarrays to this index. So what do you think? Number of subarray to this index will be 1 only. Yes. Suppose left is also pointing to same index and right is also pointing to same index. So suppose count we will take and count will be 1. Okay. Now I am saying move this right pointer to this. So basically I want to calculate all subarrays from this to this. Okay. And you know till here you have already calculated. Okay. So I am saying calculate number of subarrays which ends with this number. So what do you think? First will be this and second will be this. Yes or no? Yes. So can I say when my R was 0, my number of count was 1, and when my R was 1, my count was 2. Why 2? Because when R was 1, first count and second count. Yes. Now I will move this R to this index. Now you tell me how many subarrays can be there which ends with this. Why I am saying which ends with this? Because which ends with this and which ends with this you have already calculated earlier. So tell me how many such subarrays are there. So first is 1, then 2 and then 3, correct? And what if I'll tell you this is nothing but the length till now? Yes. Length means R minus L plus 1. So basically the count will always be R minus L plus 1. Here also R minus L plus 1. Now here when R was 2, your count was 3, and 3 is nothing but again R minus L plus 1. Why? Because R is 2, L is 0 and plus 1 will make it 3. Again let's check with another example. Let's move this R towards this side, and now when R will hit this, number of subarrays which ends with this number is 1, 2, 3, 4, correct? Yes. So hence I can say when R was 3, count was what? 4, and this is nothing but again right minus left plus 1. Yes or no? Yes. Sorry, 3. So total 4. So hence can I say कि basically I have to move my right ahead, and number of subarrays I can simply find when I will keep on adding this right minus left plus 1 to my count. Yes. So basically in the count I will add everything, this, and this, and total this is nothing but 6 plus 4, 10. And if you will find there are 10 subarrays which we can find with this. And now we have to find the valid subarrays, and that valid condition we can simply check in the if condition. If the product is less than, then only we will count, correct? Okay. So with this we can come here and we can write the code. So how? Initially my right pointer is here. So what do you think? How can we calculate the length? Again, how? Count plus is equal to what? Right minus left plus 1. And if you will find right is at 0 index, left is also 0 index, and plus 1 means 1. And definitely the number of subarrays which ends with 10 from left side is only 10. Yes. Now you calculated the length, but have you checked it was valid also or not? What if it was not valid? So means I am saying what if after multiplying that number this condition is not valid, then what you will do? So basically let's move it here, and now we have to write the case. Ki what if my condition fails? So as of now my condition does not fail. So let's move our right pointer. So my right pointer will point to what? This 5. Now again in the product 5 will also get added, and total multiplication is 50. Correct? So we will still add the length. Okay, we have not checked the base case. We will write the condition here. But let's say as of now it's all passing. Yes. Next time again right pointer will go to this side. Now if you will see, this will become 100, and 100 we did not expect it. So basically before counting the length you should have checked what? Length, correct? Yes. But as it fails, so you already know, expansion we do until the condition is true, and once the condition fails, we start what? Decrementing, means shrinking phase, and shrinking will always happen from left side. Again, till what condition? So you remember in sliding window previous questions also, we moved this left pointer until the condition again becomes true. So we will keep on moving this left pointer. So for moving one time we can use if loop, but you know we have to continuously move this L pointer ahead until the condition again becomes true from false. So hence we need to add this in a while loop. Yes or no? Yes. Yes, we will use a while loop here. So we will say while our product is greater than equal to k. Why? Because if it is less than, then only valid. Until it is greater than or equal to, it is not valid. So we want the while loop to run. So what we will do inside it? As you know, till here we have multiplied everything. So in addition, when we kept on adding all these things, from left when we have to remove, we subtracted. But here we did the multiplication of each number. So to remove, we should subtract this or divide this. Obviously divide, because you multiplied in the main number na. So to remove 10, you have to divide it, correct? Yes. So what you will do? You will write product divide is equal to what? Nums of left. So you divided the number, and now you are free to move your left pointer ahead, and now you will move your left pointer ahead, and now left will point to the fifth index. Now it will check the product, and product is 5 into 2 means 10. Now the while loop will check, is the product greater than equal to k? No, it is not. So hence it will come out of the while loop, and again it will count the valid length. So now what is the valid length? If you will see, right pointer is here and left pointer is not here. Left pointer is here. So hence we have calculated this also and this also. Means we have calculated every subarray which ends with this 2, which is this 2 itself and 5 comma 2. So means 2 subarrays, and that is nothing but right minus left plus 1. So next time it is a valid case, again the right pointer alone will move ahead and it will multiply what? 5 into 2 into 6, that is 60. Again, is this greater than k? No, it is not. Again, what is the total number of subarrays will get added? Extra subarrays. That is nothing but right minus left plus 1. Again, 3 length extra. So now if you will see the total number of subarrays, so the number of subarray which ends with 10 was only 1. Now the number of subarrays which ends with 5 was this also and this also. So total 3. Now the number of subarrays which ends with 2 was this and this. So total 5. Now the number of subarrays which ends with 6 is this, this and this. So 5 plus 3, 8. So total number of subarrays was 8. Now let's see the time complexity here. The for loop will run for r, and where r is running from 0 to n minus 1. Correct? Yes. And now if you will see this while loop where we are checking this product less than equal to k, so we are moving the left pointer also ahead, correct? But in total if you will see, every pointer, if left is moving ahead, it is not coming again back and restarting. No, so every point by right pointer is touching by one time, and at max the left pointer can touch every point if condition fails. So in total O of 2n time complexity. But if still you feel ki how we can calculate, after this also if you cannot feel ki we understood, then you can simply dry run and you can count the number of such ways. And what is the space complexity we have used here? We have only taken this left variable to initialize the product variable and then count variable to store our all answers. So total 3 variables we have taken, so hence space complexity is still constant. Now the same code we can type here in our code editor. So the very first base case was, if you remember, if my k was less than equal to 1, which we have already discussed. Why? So we will return 0 because there will be no such subarrays. After that we will initialize our left variable with 0 and our count variable to store all such subarrays count here. And we want to initialize our product with what? 1. Yes. Now after this we will run a for loop for right variable, correct? And we will initialize with 0 and we will allow this to run till what? Nums dot length. Okay. Now it will go and we will do right plus plus. Yes. Inside it our task is to multiply the current number in our product variable. So we will multiply nums of right. Yes. So after the multiplication, our task is to check if this is valid or not. So in a while loop, we will check ki if our current product is somehow greater than equal to k, then we have to start the shrinking phase. And in the shrinking phase, we will simply divide the nums of leftmost element, and after dividing, we will do left plus plus. And after all this, we will simply increase our number of count subarrays, and which will be nothing but right minus left plus 1. this will be the total number of subarrays. And after coming out of this loop, we can simply return the number of such counts. Sorry, my bad. Now all get passed, and now let's submit this. And you can see 99.81% because the total time complexity is near to 2n, which is nothing but O of n only. And hence it is the fastest solution compared to the O of n square solution. So with this, we can go in our sheet and we can mark the fourth question, which is subarray product less than k, and it was also one of the important questions according to the interview perspective. So I hope this video was clear and you understood each and every concept and why we did this, and I hope now you start recognizing how to apply sliding window and when to apply two pointers and other concepts. If not, then all the patterns of array we have already discussed in our very first video of the playlist. You can definitely go and check it out. And if you are new to this channel, then definitely we are following the Rising Brain sheet that is pattern wise, freely available. All the links you can find out from the description, and if you want to connect with me on Instagram and any other social media platforms, then all the links I will definitely add in the description. You can connect with me, and if you need any kind of help and support, definitely reach out to me. And that's it. Let's meet in another video with some more interesting topic. Till then, keep learning, take care of yourself and your family.